Hello students, so today we'll be starting the Robotics and Artificial Intelligence course of ICSE. The code is 66 and I have already made several videos for class 9 and even class 10 videos are there, and in particular I'll talk about the robotics section and the very first chapter, which is New Age Robotic Systems, and I'll be following the syllabus of this ICSE curriculum. Now this is the video where we will talk about the relevance, the need and the variety of NARS systems, and you can check the playlist. There you will find that I have already made a video on the components of robots as a system. Okay, so with this, let's start today's video. Okay, so the first thing is, what are NARS? You see, NARS are advanced interconnected robotic systems that leverage artificial intelligence, machine learning, sophisticated sensors and even cloud connectivity. And why? So as to perform tasks, that is to make our lives simpler, okay, to help us. Now, what's the difference with traditional industrial robots? Now, the difference is that NARS, you see, isolated, caged, and they perform single repetitive tasks. Now, this is the feature for traditional industrial robots, not NARS. That is, you see, traditional robots, they are quite isolated, caged, and perform single repetitive tasks. So what do we need right now? Basically, as you can guess, NARS is characterized by the first thing, autonomy and intelligence. That is, they can make decisions based on the real-time data. So you are making a machine which can make decisions based on the changing scenario. That's great, because when you are giving an instruction, you are thinking of a particular situation, but the situations can change, environments can change. So basically, you have trained your system, NARS system, in such a way that even in the changing scenarios, it can work based on its own data, okay, that it will be taking. It will be able to understand the environment, the changes in the environment, and then it will be able to make decisions and work accordingly. So that's the greatness of NARS compared to your traditional industrial robots. Okay, now collaboration. What's that? Well, you see, they are designed to work alongside humans. So such robots are also known as cobots. That I'll tell you in the second chapter. Cobots. C for collaboration. So in robot, if you replace R with C, basically it means now we have cobots, which are collaborative robots. They will work alongside humans. They will not harm humans. They will take into account the human around them and then work accordingly. Okay. Now, another great thing about them is adaptability. That is, they can learn from their environment and adjust their actions. This I have already told you, right? What about connectivity? Well, you see, they are often part of the Internet of Things. And what's this technology? Well, IoT is a technology which generates data, right? Basically, you are connecting any machine with the Internet, and that is the technology of IoT, right? And so they are often part of the IoT, so that they are connected with the Internet. So if you have a machine at home, a NARS machine, and you are sitting in your office, then from your office you can basically understand, get knowledge of what the machine, the NARS machine, is doing right now in your home. Okay, so basically sharing data to optimize larger systems. Okay, so let's move forward. Well, you see, their relevance stems from solving modern challenges. You see, compared to previous times, modern days, we have got much more complicated life. So we need more efficient machines, which will help us make our lives simpler. Okay, help us in daily life. So basically, what we need is boosting efficiency in e-commerce, assisting in aging population, improving safety, and performing tasks in inaccessible or dangerous environments. My dear students, I will ask you to look into the various videos of class 9, where I have talked about the various types of robots that actually work, real life examples of the robots that actually work in these various scenarios, so you can get an idea. Okay, now you see NARS, now they are possible due to the concurrent advancement in compute power, computer power, sensor technology, and AI algorithms. You see, without these three things, and also data science improvements, all the data that is being generated, we have to analyze it. Okay, so if there hasn't been any development in these technologies, then making NARS system would have been almost impossible. Okay, so now let's talk about the NARS categories with examples. Well, the first is warehouse and logistic robots. Well, what they are? Effectively robots that automate the entire supply chain within a warehouse, from receiving to shipping. Now, some of the examples. Well, the very first example is AMRs, which is basically, you see some example, Amazon's Kiva robots. Let me show you some pictures. You see, so you don't see any human beings around, so it's a warehouse and all work is being done. See what is being done over here. The robot, this is sort of imprinting. You see FedEx is written, so delivery work, all the manual labor work is being done by the robots. See the loading, unloading. Okay, so everything is being done here by robots. So Amazon's Kiva robots are the classic example. They autonomously navigate vast warehouses. These ones, you see, these ones, they navigate, move around vast warehouses, moving entire shelves of products to human workers. Now, there will be people out there. So, basically, in the warehouse, you will find a section where we have got NARS robots, and then we will have human robots. So, not entirely humans are being replaced. You have to keep this in mind. Okay. Now, so basically, but we will require much less humans. And remember, these robots are much more efficient. You see how these drastically reduce walking time and increasing efficiency. So this means faster and more accurate deliveries. Well, you see, another example is automated guided vehicles, AGVs. So these are basically driverless pellet jackets and forklifts that follow predefined paths along magnetic strips to transport heavy goods. I have just shown you an example like this somewhat. Okay, now again we have robotic sorting arms. So this one is yet another example of this, a robotic arm. You have seen the KUKA robot like that. Just an arm is there which is doing high speed. You see, high speed arms, they are equipped with vision systems that can identify, grasp, sort millions of packages with high accuracy for companies like FedEx and DHL. So this is just like a movie, sci-fi movie, but the difference is that this is reality. Okay, anyway, now what about assistant robots, which are for professional and domestic users? Well, as you can understand or guess, these are the robots which are designed to help humans with physical or cognitive tasks, either at home or in professional settings. Look at some of the examples over here. You see the iRobot Roomba, which is basically a vacuum cleaner alternative. You don't have to do this. Yes, this one is the iRobot Roomba. It just moves around. A child is playing, no problem. It will take this into account. It will avoid the child, avoid all the obstacles. Look, it's just below the chair. and it is again taking away some possible garbage, dirt and all that. Now there are another examples like Ecovacs Dbot, which is for mopping and vacuuming, then Liku, which is a social robot for companionship and smart home control. We have robots like this, you see. These are professional robots. See, Boston Dynamics Spot is used on construction sites. So this is basically used for construction sites to scan and monitor progress, and also in hazardous environments like nuclear facilities for inspection. Well, another example is that of Molly robots. See, humanoid type robots which are for help. You see, this is a kitchen robot. So many arms, two arms are there. And people are just watching, you see. Well, Molly Robotics have developed a fully automated robotic kitchen that can cook meals, you see. Okay, now next is the smart environment scenario for homes, schools and cities. Now what are they? Basically environments where robotic systems and IoT devices are integrated to automate and optimize functions. Again, let me show you some examples. It's much better. You see, pictures convey more realistic feeling. They are much more friendlier compared to language. You will be at ease. Now just look at them. What do you observe? Let's then talk about, well, the first thing is smart home. So basically a Google Nest thermostat learns your schedule over here, this one. Okay, it learns your schedule, adjusts the temperature for efficiency, and then we have got this smart locks. Okay, lights and appliances can all be automated or controlled remotely, creating a robotic environment. Well, we do have smart school, which is basically AI powered tutoring system that adapt to a student's learning pace. Even telepresence robots are there, which allow sick or remote students to attend class and move around the classroom. Now, what about smart mobility? Now you see integrated city systems like smart traffic lights are also there that adjust timing based on real-time satellite flow to reduce congestion. You see, there is a traffic signal and there is a robotic system. It is analyzing the data, and this is just an example of your smart school. So smart classroom, CCTV security, GPS tracker of individual students. Well, Wi-Fi connectivity, digital entry, everything is being connected. Okay, now let's next talk about autonomous and driver assisted vehicles. Okay, now you see, what are they? They are basically robotic systems that perceive their environment and navigate without full human input. Some examples: autonomous cars like Waymo's self-driving taxis. They are already providing fully autonomous ride-hailing services in select cities. Now, they use a suite of LiDAR, radar and cameras to create a 3D map of the world. Okay, now we also have driver assisted cars. So examples: Tesla's Autopilot and GM Super Cruise. They are advanced driver assistance systems, ADAS, which can basically automatically steer, accelerate and brake within a lane on highways. Now let's talk about autonomous drones, which are basically unmanned aerial vehicles or UAVs. So they are effectively, in common language, they are flying robots that can be remotely controlled or operate autonomously via pre-programmed flight plans. Some examples: well, what about delivery? We have got Wing from Alphabet or Google and Zipline. They use drones to deliver packages and also critical medical supplies like blood and vaccines quickly. Now in agriculture, drones equipped with multi-spectral cameras, they often fly over fields to monitor crop health, optimize water and pesticide use and also survey land. What about infrastructure inspection? Of course, it's also possible with NARS, Well, we have autonomically inspecting power lines, wind turbines, and bridges for damage. As a result, humans, we don't need them in dangerous situations. So such dangerous situations are handled by robots. Now, we are not forgetting medicine and healthcare. Well, we do have robots, the NARS robots that assist in surgery, rehabilitation, diagnostics and support care. Now students, I will ask you to look into my class 9 videos, and there I have talked about so many real life scenarios, including the Da Vinci Z surgical robotic system, which two of my family members have gone through, okay, and they are very successful. So just look at them. See, what is Da Vinci surgical system? Basically, it allows surgeons to perform minimally invasive surgery with enhanced precision, flexibility and control. And we also have rehabilitation robotics like exobionic exoskeletons, and these help patients with spinal cord injuries to relearn to walk and regain mobility. Okay. Now, what about hospital logistics? Of course, this is also handled by robots. So, UVD robots autonomously navigate hospitals and disinfect rooms using EVC light, reducing hospital acquired infections. Wow! Now, next we have companion robots like Paro, which is a therapeutic robot seal, and it is used in dementia care to reduce stress and anxiety. Now, let us look at some other examples like that we often see, the everyday robotic system. So, what about an elevator? Is it a robot? Well, you see, elevator is a robot. Why? Because it has got sensors, buttons, user input, weight sensors to prevent overloading. You will see that sometimes it is written only 8 persons allowed. So how is it doing the calculations? So it is effectively doing calculations like 65 kg average per person into 8, something like this. So what is the result? The result is, if there is more than 520 kg weight in the elevator, it will give an alarm and say that please decrease the weight, otherwise the elevator will not work, it will be stopped. So see, this is to prevent overloading. And also we have got light curtains which will detect an object in the doorway and prevent it from closing. Okay. Now in the elevator we also have processing, which is basically a central computer that takes all the sensor input and it decides which floor to go, in which order, and how long to keep the doors open. And we also have actuation, and it acts upon its environment through powerful motors to move the cab and actuators to open and close the door. So you see, this is an amazing concept. Probably you haven't thought about it. Now, you see, in modern times, we have got smart elevators in skyscrapers having more than 30 or 50 floors. Okay, story buildings, skyscrapers, and they basically use AI to optimize traffic flow. So you tell a central panel your floor and it assigns you to a specific elevator to minimize waiting and travel time for everyone in the building. And this is a brilliant everyday example of NARS in action. Okay, so why are NARS relevant and why is it possible? Well, we have already talked about some of the important concepts. Let's just recap them. Okay, now relevance. Well, you see, what about efficiency and economics? Well, they solve labor shortages and optimize logistics, crucial for the global e-commerce economy. Now, when I say labor shortage, I mean specialized people. Labor, specialized people. They are not in a way replacing humans, but sometimes for a particular job we'll need skilled people, skilled laborers, but they are often not available. So if we have less skilled humans, then that gap can be filled with NARS robots. Okay. Now, what about safety? Well, they perform dangerous tasks like disinfection, inspection, and in hazardous zones. Also, they enable new possibilities in surgery and manufacturing. We have seen the Da Vinci Z surgical robots in action. Now, what about aging populations? Of course, they provide physical assistance and companionship for the elderly. And remember, we have got data driven insights. So, they are in fact collecting large amounts of data. And why? So as to improve various processes. So, if you have a NARS robot, okay, so that robot, when it performed tasks yesterday and it is again performing the same task today, the difference will be that today it will be already optimizing the work based on the data that it has done for the last time or even before. So suppose you have bought a robot for last 6 months, so every day after work it is analyzing the data and again it is trying to optimize how to perform in a better way. Okay, and this is very important for crop yields, for energy saving, okay, in buildings in particular. Now the next question is, why is NARS possible now? As I told you, because of advancement in AI and machine learnings, and this allows robots to learn from data and adapt to new situations. And we have got cheaper, better sensors like LiDAR, high resolution cameras, and torque sensors are now available, which are not only cheaper but very powerful as well. Now also advancement in computing power. Now we have small energy efficient processors, GPU, TPUs, which can handle massive computations needed for real-time perception and decision making. And last but not the least, we have got 5G and IoT technologies. So, and this enables real-time data transfer and cloud-based brains for robots. Okay, so we have come to an end of this chapter. So, if you have any comments, do write me in the comment box.